Hello and welcome to the Collecting Results by Threads video. It will demonstrate how AQtime Pro saves profiling results for multi-threaded applications and why this is helpful for result analysis. AQtime Pro supports profiling multi-threaded applications and collects profiling applications by threads so that you can see what code was executed by individual threads during the application's run. So let me demonstrate how AQtime Pro saves profiling results for multi-threaded applications. In our example today, I'm going to use this removing duplicates sample application. This application generates two arrays of both integers and string items, and then returns the new sorted arrays with all the duplicate elements removed. The removal of duplicates is handled by this function right here, remove duplicates. This function executes two threads simultaneously. In one of the threads, the function removes duplicates from the array of integers. In the other thread, it removes duplicates from the array of strings. So to estimate the actual performance of the remove duplicates function, we need to know the execution time in each thread, and AQtime Pro allows us to do this. So the first thing we want to do is switch back to AQtime, and we want to create a new project for our application. So to do this, I'm going to click the Create a New Project from Module button right here, and that's going to bring up this Open File dialog where I can browse out to where my executable lives. So here's my application right here, removing duplicates. I'll click Open. And now AQtime is going to create a profiling project for our application. Alright, now once we've done that, I'm going to choose the performance profiler from the list of profilers that are available. And then I'll press Run to start the profiling process. This invokes the Run Settings dialog box. This dialog allows you to configure a number of settings that have an effect on the profiler's functioning. So let me focus your attention here on this thread model option. This option specifies what thread model AQtime will use to gather profiling results. If you select Win32 threads, the profiler will group results by operating system threads. If you choose CLR threads, the profiler will gather results by managed threads. Now remember that operating system threads differ from managed threads that may exist in .NET applications. Managed threads are controlled by the CLR, so it can create one or several operating system threads to manage a single managed thread. And then the final option, COM threads, means that AQtime should analyze logical threads when a COM server works with several COM clients simultaneously. In today's run, we're going to use the Win32 threads model. So I'm going to select that and press Run. Okay, AQtime is now launching the profiled application. And inside the application, I'm going to generate some arrays. So we're going to click the Generate Arrays button. And this will cause the application to create two arrays of 10,000 values each. Then I'm going to click the Remove Duplicates button. And now the application is going to remove duplicated elements from the arrays and display the resulted arrays in sorted order. So now I'm going to close the application down, and AQtime will generate our profiling results and display them on screen. As you can see, AQtime organizes its results into three categories: routines, source files, and modules. Source files and modules let you view summary profiling results for each source file and module in your application. The routines category contains results for every single routine that was included in the profiling run. Within the categories, the results are grouped by threads. Here we can see that our application executed on three threads. There's the main thread, the processing int array thread, and the processing string array thread. Now you may be wondering how AQtime recognizes which thread is which. Well, by default, AQtime is going to refer to threads based on their thread identifiers. And those identifiers are integers that the operating system assigns to a thread when it's created. That identifier isn't very descriptive, and it may be difficult to find the correspondence between an integer-based identifier and the application's actual threads. So it's easier to analyze your profiling results if your threads have descriptive names. Now, you can assign descriptive names to threads using AQtime's SDK, and we actually have a video about that up on our website. It's called Extending AQtime's Functionality Using the AQtime SDK. You can check that out. But if you've got an application that's written in the .NET framework, specifically versions 2 or later, you can also assign names to threads using the thread.name property. And then those names that you assign will be used instead of the default integer-based identifiers in the profiling results. So in our application, I'm just going to jump back into Studio here. In our application, you can see I've assigned names to the threads directly. So processing int array thread and processing string array thread. Go back into AQtime. And those are the actual identifiers that were used in the profiling results. So now by selecting a thread in the Explorer panel, you can see what functions were called by that thread during the application run here on the report panel. Now the results also contain this all threads group. This contains cumulative results for all the threads. So let's look at the results of this group. So I'm going to double click on all threads here. And now in the report pane, I can see the total results for all the profiled functions. So I'm just going to sort on time with children here because I want to find the slowest performing function in my application. And according to my results here, this remove duplicates guy that I've got highlighted is one of the slowest performing routines that we profiled. Now, as you recall, our application is actually calling this function in two threads, and the hit count column that you see right here is showing us that this function was actually executed twice. The time with children column right here displays the total time spent on calls to that routine in several threads, and that includes calls to child routines as well. But it's difficult to estimate the performance of this function just based on this value because the function's execution time can differ significantly in different threads. And so in this case, what we need to do is analyze how fast the function actually performed in each thread. Okay, so if we look at the main thread here, and look through the routines, we notice that the remove duplicates, there's no results for this guy right here. It wasn't called. So we know that this thread is not calling remove duplicates. So now we're going to go over to the processing int array thread. And we can see that processing int array called that method, and it took about 50 milliseconds in order for that to execute. Now if we come down here to the call tree panel, we can see that the remove duplicates function that we called here called the remove duplicated integers function as a child routine. Okay, so that makes sense because that's actually removing duplicates from the array of integer values. If we look up here at the processing string array, we can see that remove duplicates took 633.58 milliseconds, so much longer. And in this case, we see that remove duplicates is calling remove duplicated strings. So in looking at this, we can see that removing duplicates in the integer array is much faster than removing duplicates from the string array. Now this could depend on the data type. Operations on strings typically take more time than operations on integers. Or it could depend on how those functions, the remove duplicated strings and remove duplicated integers functions, are actually being implemented. So let's look at the source code of the remove duplicated string function. So to do this, I'm going to select it here in the reports panel, and then I'm going to switch over to the editor panel, and now I can actually look at the code that makes up that function. So in looking at this function, we can see that two list objects are used. Source list is our initial array, and final list is a list that's only going to contain unique elements of that initial array. So after we've removed duplicates, only the unique values will be what's left. So before adding an element to the final list, we use this contains method to check to see if that element's already in the list. This method compares a current value with each and every other item in the list, and if it doesn't find that item, then it adds it to the list. So now let's take a look at how the remove duplicated integers function is implemented. So to do that, we'll come back up here, and we'll look at remove duplicated integers code. And again, like the remove duplicated strings, this is also using two list objects. However, in addition to that, it's also using this dictionary. And for each value in the initial array, the function is calling this dictionary contains key method to check to see if the value's already been added to the dictionary. And then if it hasn't, it adds it to both the dictionary and the final list. So as you can see, this approach is similar to what we were using for the string array, but the difference is how it's actually implemented. And based on what we've seen in the profiling results, this contains key approach works much faster than the lookup of elements that we're using in the string array. So as a result, the remove duplicate integers function works much faster than the remove duplicate strings function. Looks like we found the source of our performance problem. So what we're going to do now is modify the remove duplicated strings code so that it uses this contains key method and see if that improves our performance. Okay, I've already opened the removing duplicates solution inside of Visual Studio here and loaded up the appropriate code file. Now this file actually already contains two implementations of the remove duplicate strings method. One implementation uses the non-optimized approach, which we've seen already, and the other is going to use a quick approach, which will use the dictionary approach that we saw in the remove duplicated integers function. So in order to determine which one of these routines is going to be used, come up here to this define statement, and you'll notice that this statement is actually commented out right now. So that means that the application is going to use the non-optimal approach to removing duplicate strings. So I'm just going to uncomment that. That's going to enable my faster version right here, as you can see, and you'll notice that the old version that is slower is now grayed out. So now I'm going to save my changes and rebuild my application. Alright, so let's see if our application is going to work faster or not. Coming back into AQtime, you can see that AQtime has automatically detected there have been changes here. So we're going to say yes, we want to reload our application. And we're going to reprofile our app. So I'm just going to click the run button again. Okay, I've fast forwarded a bit. I've already reprofiled my application and generated some results. So now let's check to see if our remove duplicates function has sped up. So here we go. We're going to come to our all threads section here, and we'll look at the remove duplicates function, and you'll see this time around remove duplicates only took about 47 milliseconds to get called, so that's an improvement of our previous run here. If we go back to our previous run, we can see that remove duplicates previously took 684 milliseconds, so we've sped that up quite a bit. So now let's look back at the processing string array there. We can see that the remove duplicate strings function is now taking 5.46 milliseconds compared to the old value of 625.48 milliseconds. So we've sped this up considerably by improving the performance in the remove duplicate strings function. This concludes our video. You've seen how easy it is to analyze multi-threaded applications with AQtime. Organizing results by threads lets you quickly find bottlenecks in your application and eliminate them. Note that this feature is only available in AQtime Pro. AQtime Standard does not provide this functionality. And for additional information, please contact us at our website, smartbear.com. Thanks very much for watching and have a great day.